All right, good afternoon, everyone. Today, we are going to take a look at pointers. So the idea, it is a new concept, but it shouldn't actually be that strange to us. We kind of fiddled with the idea already when we were dealing with arrays. So this week and next week, we're going to kind of take a deeper look at the actual mechanical implementation of that. So let's start with pointers. So what is a pointer? A pointer is a special type of a variable. So the pointer itself is the data type. That's a special data type. And a pointer is simply it's able to store an address. So that's what pointers store. They store some memory address. And there's two ways you can use a pointer. You can use it to retrieve that address, or you can kind of use it like a regular variable, which what is a variable? Well, a variable is a reference to a memory address. And you go to the address and you get the contents. You can use a pointer in the same way. You can store an address and you can either use the address, or you can say, go to the address and get me this stuff, kind of like you would with a regular variable. So in memory, perhaps it would look something like this, right? So here we have an integer, x equals 10, and that, of course, this is not real. Maybe it's stored at memory address 1. Okay, so let's pretend that's the actual memory address. And every time you type in X, it goes to that memory address and retrieves this. A pointer, let's say X pointer, for example, is able to store a memory address. So notice here, we wouldn't put the number 10, but instead I would put the address of that variable. So X pointer, and we'll talk about all the syntax in just a moment. So here I have a int pointer, X pointer equals, and the ampersand means the address of X. We've used that before already with scanf, right? So we kind of know what that means already. It means the address of something. So I want to store the address of X. Well, the address of X is 1, and that's what I'm going to put right here. Now, X pointer is a variable, and it also, you use it again, kind of like a variable. It has its own address. So again, I mentioned there's two ways you can use it. If you just type in the variable name, it will go to that address 2, and it will retrieve this value, which happens to be an address. The other way you can use it, which we'll discuss in a minute, is called dereferencing. And instead, it will go to this address and it'll look here and say, hey, go there instead, and reference and retrieve that item. So how do you make pointers in C? You make a pointer by writing in a data type. Now, even though the pointer itself is the data type, in C, data types have differing sizes. So when you go to an address and say, read this variable, it doesn't always read just one memory cell. I know that's the way I keep drawing it in these pictures, but this is not real. This is an abstract view of memory. In reality, that integer is maybe 4 memory cells or 8 memory cells. And when you say, go read this variable, that memory address, let's say address 1, is just the beginning of that region of memory, and the computer knows how many cells it needs to read. It'll read all 4 cells and interpret it appropriately. So pointers, they kind of behave the same way. Here's an address, but I still need to know how many actual cells to read to interpret this data. What are you pointing at? Oh, I'm pointing at an integer. I'm pointing at a double. I'm pointing at a string. Here's how many things you need to read if you want to interpret it correctly. Right? So you still have to write in the data type for that reason, so that it can interpret the data correctly if you dereference it. Notice that dereferencing, note that dereferencing happens automatically with regular variables. So anytime I type X, for example, it automatically goes to that address and retrieves that value. So it's dereference, it's a form of dereferencing. That happens automatically for variables. It doesn't necessarily for pointers. You need the asterisk and then a variable name. So aside from the fact that we put an asterisk right here, you create pointers the same way you create any other variable. Data type, variable name. The only difference, you put an asterisk in the middle, that means this is a pointer. How do I set it to a value? So there are 2 ways that we can do that. Today, we are going, today we're going to look at setting it to an address that already exists. The computer already allocated memory for some variable, and I'm just going to point to that. Next week, we're going to look at how we could make our own memory. We can allocate our own unnamed variable if we would, and we're going to point to that space instead. But this week, we're going to point to something that the computer made for us in, for example, this instruction here, right? The computer already went and allocated some memory for us. I didn't have to do it, and I'm just going to point to it. And you do that simply by using the variable name and setting it equal to ampersand, whatever that variable is, right? Obviously, if it's another pointer variable, I wouldn't need the ampersand. There's already an address there, right? So the idea here is just I need to put an address in here. So if you use it like a regular variable, that's what you're able to do, store or retrieve memory addresses. The other way to use it, as I mentioned earlier, is to do something called dereference it. If I don't actually want this, but I want that, then I have to dereference it. I don't use it like a regular variable. I put an asterisk in front of it again. So if you put an asterisk in front of a pointer variable, that tells the computer that I don't actually want this. I want to go here and get that. All right. So quick question, just a quick little quiz. Here we have x equals 1. So x, again, let's use our fake example. Pretend x is stored at address 1. My pointer equals whatever the address of x is. And we execute this command, my pointer equals 20. So now I'm going to change this to 20, because when you dereference it, that basically means you get to use that cell. You can either read it or you can change the value. You can use it as if you were that variable. Now, here's another line. Int y, I'm going to make a new variable and I'm going to set it equal to, I'm going to dereference it, so whatever that's pointing to. So y equals 20. Next instruction, I'm just going to change x to 2. Change my pointer to 2. I'm not going to do anything with y. And then I'm going to execute this instruction right here. What do we think is going to happen? Why is it an error?
Well, because if you wanted to actually change that, you'd have to put the asterisk in front of it to change the value. At this point, it already has a value.
There we go. This is an address variable. And if you don't dereference it, you're using it as an address variable. What I'm saying here is I want to change the address you're storing to 3. And you're probably not allowed to go to that memory address. If you were, it would let you do it, but you're probably not allowed to do that. Very good. And here is kind of that example we just looked at, right? X equals 10. I'm going to set the address in my pointer equal to whatever x's address is. So we're going to put a 1 right here. Y, I'm going to set that equal to, I'm going to dereference that. So that there, if I dereference it, I get 10. So I'm going to put a 10 right here. This is y. But now y and x are just regular variables, right? They're not necessarily linked to each other. If we make this change, I dereference x pointer, I go to address 1 and I change it to 20. I didn't just change my pointer variable, right? I actually changed x because I'm storing the address to x. So we're kind of linked because I'm storing your address. So anything I do to this dereferenced variable is exactly the same thing as if I were to just say x equals 20. It's identical. They both kind of point to the same memory address, right? That doesn't change y. Y is just a regular variable, right? So making this change doesn't affect y. Y has its own memory address. I didn't actually go in there and update that. Same thing here. If I change x to 11, now if I were to go back and dereference x pointer, I'd get back 11 because we both point to the same memory cell. And again, y hasn't really changed. So let's, before we do the exercise, let's do a quick, let's just take a look at the code here. Let's do it here because I get color here. I don't get color in JGrasp, unfortunately. If we look at our code, here's our code. What do we see? I see, let's open it up in Vim. What do we see? We can see we have integer called num. I have a pointer variable called num pointer, and I'm going to set it equal to the address of num. And then we're going to print some stuff, right? So here we can actually just run the program and see what it prints. So just so you can see that, let me see, let's do this head and 10 maybe. Yeah, we just do that. So here's our variables. And if we run the program, what do we see? So what is the address of number, our integer variable? There's the actual address. So again, not the made up one we had. This is the 0x means it's given us the address in hexadecimal, 16-digit numbering system. There's the address of num. Here is the address of our num pointer, right? So we have, that's the address of our num variable. That's the address of the num pointer variable. So in our PowerPoint picture, that's 1 and 2. That's what I just printed. I just printed 1 and 2. And then what is stored inside of num pointer, you can see here, that matches that, right? So all I did was I saved the address of this into that variable. So you can see they match, sure enough. And then if I were to print the values, well, num has 10 inside. And if I dereference num pointer, it also has 10. And you can see that right here. So if you type in just that, I'm not dereferencing it. What am I going to get back? I'm actually going to get back that address if you use it that way. If you do dereference it here, notice I have an asterisk. If you do dereference it, what are you going to get back? You're going to get back the thing at that memory cell, number 10. First exercise. So let's try to do this one together. If you have your computers with you, go ahead and try to do this exercise. Make a couple of variables, integer variables. You're going to make a pointer variable, and then just follow the instructions here, right? Set X pointer so that it can save the address of X, and then make some modifications using these, following the instructions here. JGraph's not pretty color. All right, let's do this part again. Someone help me out. How do I make a pointer called X pointer and store the address of X? How do I do that? Just like that? Anyone else? So remember, we're making a pointer variable. X is a regular variable. Normally, when I type in X, what am I going to get back? Whatever happens to be stored there, right? So if we look at our PowerPoint, if we go back, if this said this is our picture, if I typed in X, what would I get back? 10, right? So I would be storing the number 10 into X pointer. Is that what I want to do? That's not what I want to do, right? So how do I tell it the address of X? Because that's what pointer variables are. Pointer variables store addresses. We have used this before. Where have we needed to provide an address to a variable before? We've needed to provide it to a certain function that we've used in here. Scanf, that's right. And how did we do that? With the ampersand. So we need to use the ampersand that says the address of X. Very good. So there's our second bullet point. So we're going to change Y to 10. That's pretty straightforward. Y equals 10. Now we need to dereference X pointer. So X pointer is pointing, or it's storing the address of X. So I want to go to that address and I want to change that to 20. How do I do that? How do I use this variable to somehow modify to go to that address and change that value to 10? So I have in parentheses here, I have a hint. You have to dereference it. You need an asterisk where? Very good. We need an asterisk in front of it. That's how you dereference it. So here, and we'll just set it to the value. Then we use like a regular variable from there, right? So asterisk in front says dereference. No asterisk in front says use it as an address variable. Very good. That's 20. Now we want to add X and Y together. So let's see what happens. I'm just going to print a result. And I'm just going to add X and Y together and I'll print that result. Is this going to work okay? I never actually gave X a value. Do we think this is going to be fine here? If you look at line 28, 29, and 30 and 31, 29 through 30, 28 to 31, I never actually set X to anything, but I'm going to try to use it here and add it together with Y. Is that going to be okay? I see some people nodding our head. Yes. Why is it okay? That's right. This variable, this pointer variable, is storing the address of X. I actually went to that memory location already and I put something there. I put the number 20 there. I did it right here on line 31. So if I compile and run this, it should, and it did, it should print the number 30. Very good, because 20 plus 10 is 30. Now, what if, let's continue. What if instead of that, I tried to add this together? I want to dereference my X pointer. And I want to add, let's just do this for now, our placeholder, those two things together. First of all, how do I dereference my X pointer variable? Okay, what do we think is going to happen if I do this? Is it going to print something different? Is it going to work? Can I do it? Why don't we run it and see? Let's compile it. It doesn't complain. That's good. And let's run it. And look at that. We get exactly the same answer, right? So again, we're dereferencing this. I don't have to use that variable name to retrieve that value. that variable name just takes me to that memory address. But guess what else takes me to that memory address? This does too. So whatever's there, I can still read it. And if they have the same data type, or this has the same label in front of it, so it knows how to interpret that cell. Very good. What about using pointers with functions? How does that work? There are, believe it or not, quite often, you'll see C code where instead of passing values in, we'll just pass addresses in, and then you can go directly there and modify it yourself. Typically, you're going to do this for big things like arrays or structs, but it is something that is done. And as far as using pointers in as function parameters, there's nothing different. Pointers are pointers, you use them the same way, and parameters are parameters. You use them the same way, so nothing really changes. If you want to pass a pointer as a parameter, you just write a variable declaration for a pointer. That's it. And then inside the function, you use it like a pointer. So what does that mean? Let's do this. We'll make a function int, let's just say print pointer value, PPV, and we'll just pass in some pointer here. This is a pointer, any pointer. And all I'm going to do here is print the value of the pointer. I'm not actually going to change it. We know it's an integer. And how would we print not the address, but the value that this pointer is pointing to? How do we dereference that pointer and print that value? What's that? Okay, put an asterisk and what? That's right, very good. The same way you dereference any pointer, nothing changes. I'm just using it in a function. You still use it exactly the same way. If we go down here to this function now, and let's change this. We already know what that does. Why don't we just try to print this? Let's see what happens there. So PPV, and I'm going to, oh, actually I was supposed to return something, huh? Let's just, come weird. Let's do this. We can do that. Printf does return stuff. It prints how many bytes are written. So PPV, and we'll pass it our pointer. So this is interesting. Now, how do I pass it that pointer variable? This wants a pointer variable. At its heart, and it's on the next couple of slides, at its heart, what is a pointer variable? What does it store? A pointer variable stores what? An address. So really, when you say this, what you're really saying is, I want an address. You really don't care how you get the address. You can get it in the form of a pointer variable, or you can actually just give it an address. Now, we happen to have a pointer variable that we could use. How do you think we would use that? Logically, how do you think we would use that as a parameter if we're trying to pass that pointer to this function? Why not dereference it? Very good. Dereferencing it gives you the thing that it's pointing at. Just typing in the variable name gives you the address, and that's what I want. I want an address. So you can do this, or you could also have do this. You can type in the address of X or address Y. It really doesn't matter as long as you give it an address. So this happens to be an address. If we compile this and run it, you can see, sure enough, it prints exactly what happens to be at that location, right? So you've pretty much given this function that normally doesn't have permission to see X. You've given it to permission to go into that memory cell and use that information. So pointers actually allow you to cross those borders. They allow you to cross those lines, because now you're telling that function the address of that thing. Normally it can't see the address, but now you're saying, hey, if you want to go over here and modify some stuff, here it is. That's a good and a bad thing, but that is what you're doing. And here is an example. Try to demonstrate that graphically, right? So here you have your main function, and we're calling function one. What does function one do? Function one just returns whatever this is plus 10. So normally, you can see we have these two regions of memory. Okay, so that's what's in memory, and this is our made up address. Normally what happens is main has permission to access this top half. F1 has permission to access this bottom half. So when I call this function, x equals 10, right? I'm going to make a copy of 10, and I'm just going to put that copy down here, but you can't actually see that address. You can't see address 1, but you don't need to. You have the number 10, and you can just do something with it. So we have 2 copies of 10, and you're going to return 20. When you're done, we're going to copy this back into the memory space for main, right? So that's how, and that's the address of y. Y is here. We're going to copy that 20 into. So I'm going to copy things both ways. That's how it works. Parameter passing and returning things. With pointers, however, what we could do instead is just tell function 1 where x is. So now instead of giving you a copy of 10, I'm just going to say, you know what? 10 is at address 1. And what gets copied into F1 is the address. And now that F1 knows where that's at, you can see I can just go straight there and change it. I don't have to make another copy. I don't need 2 copies of everything. I'll go straight to X1 and I'll just change the value myself. And you can see right here, that's exactly what happens. F1 has permission now to go up here and modify that value to 20. And this we kind of already talked about, right? So if we had a pointer variable and we needed to pass it as a parameter, how could we do it? It really doesn't matter. That's an address. This is also an address. Either one of those is acceptable. I want to show. All right, we'll go to the second example. So again, here we have 2 functions. So I'm trying to draw a representation of what's happening in memory. We have 2 functions, and main is allowed to access this part of memory, and mod pointer, that function is allowed to access this part of memory. And we can see here, we're going to start our code, x equals 10, x pointer equals the address of 10, so we're going to store 1 here. And mod pointer, where's the code for that? We're going to call mod pointer and we're going to pass it this address. So here we call that function, and that address of 1 gets copied into this memory region for mod pointer. And inside, where did I have that code at? Is that this code? Okay, I thought I had the code somewhere. I apologize for that. It's kind of confusing, I realize, because I should have had the code written somewhere where it's clear, but this is the code for that mod pointer function. It just, whatever you're pointing at, it changes that value to 20. And you can see I have the address 1 here. So I'm allowed to go straight to that address and change it directly to 1. I don't need to make another copy and pass it back. Now I can just go directly there and modify it myself. So next exercise, let's try to create a function, and I kind of did it already in JGraphs, right? But create a function that will accept a single pointer as input, and then try to do kind of what we're doing here, modify it somehow. Here we just want to multiply it by 2. And then in the main, call it and give it the number 22. It should change that value to 44, right? If you multiply that by 2. All right, what do we get? We should have gotten something similar to this, right? So here in our function, what we want to do, we don't really need this, right? What could we do here? Now that we're able to go and modify the value ourselves, we don't really need to return anything. Now, often you'll see a lot of times functions that work with pointers in C that also return something. Typically what they're returning is some kind of error code. So I'll have a list of error codes represented by some number. And when the function is done, they'll return one of those numbers, depending on whether there was some type of error or some issue. No error, maybe return 0. So you see that a lot at the main, right? We'll see at one of the very last instructions is return 0. That means this function had an exit code of 0. There was no errors, no issues with this. We exited normally. If you did have an error, there are a number of error codes you could actually return that would mean something. So when you run the program, you could look at the error, you could look at the exit code and see if it exited with errors or anything. But let's just make it void. We don't want to return anything. And we will just modify that pointer. Now, how would I modify what that thing is pointing at to change it so it could multiply it by 2? How could we do that? I know we can use the shortcut, times equals 2. So what if something goes in front of this, what am I multiplying by 2? There, very good. You just use it like a regular variable, right? Again, it is a pointer variable. The only difference is that you have to dereference this instead of typing in the variable name. And that should change that value to 2. So here we're going to call it. And if I pass it, we'll change this to 22. And I try to print that now. We'll just print X because that's what we're working with, modifying. It should print 44, right? And very good. So quick refresh on arrays. We just talked about arrays. And remember, we said that when you're working with arrays, that variable name is really just an address. And then inside the brackets, this is some offset to that starting address. So you're providing a beginning address in memory plus some offset, 0, 1, 2, 3, and that'll take you to the appropriate variable. It's a variable without a name. They don't have names. They have addresses only, and you refer to them through their address. This will get you to the appropriate element in the array. So variable name, index of the item. You could actually access all of these also using pointer arithmetic. So if an array name is just an address, then it's practically the same thing as an address variable, as a pointer variable. And C treats them very close. There are some very small differences, but C treats them very similarly, closely enough that you can use this or this syntax for referencing array elements. So this is called pointer arithmetic. And basically you're stating the same thing that this is doing. Go to that address plus some offset and dereference that, right? So if we made an array, why don't we make an array and try it out? Let's get rid of that call. What if we made this an array that had 10 things in it? Let's do that. X pointer equals address of X. Or, we don't really need to do that now. We could, well, let's populate it. Let's do this. Let's be lazy. 1, 2, 3, 4, 5. And we'll do, I want to print X plus 0. Right, so that should print exactly the same thing as that, because they mean the same thing, right? This means go to the address of X and print the first item. This means go to the address of X plus nothing, which is just X, and dereference it and print that item. And this, the dereferencing is implicit here in this statement. And we could verify the address of X if we were to just do address of array X is P is the format specifier you use to print addresses for pointer. We just type in X here. And you can see, even though X is an array, you know, we can use it the same way we would use a pointer. If that were a pointer variable, I'd type the pointer variable name and it would give you back an address. So you can use it that the same way as well. You can see the first item is 1. And what is the address of X? X is just the starting address in memory of this. Well, there's the address of X right there. We could do, here's something neat. What is the address of, if we were to do X? Let's do this, X1, but now we have to do it this way because we're using array syntax. You know, what is X plus 1? And for this to really make sense, we need to know how big, and we'll learn about this next week. Int data type is this many bytes. That's how big an integer is. I think it's 4 in this system. So that's fine. It's okay. And we see, sure enough, the data type is 4 bytes. I should have said X1. And let's do this. Sorry. Do that. And we can see COO. Oh, this is the important thing. So that's byte 0, and that's byte 4. And how big did we say an integer was? An integer is 4 bytes. So we could see that the address of X plus 0, which is just X, is right here. That's the important thing. And the next one over, if I add 1 to it, I skip 4 bytes, and that's how big an integer is. So the next integer in this list is, if we were to print it, it'd be the number 2. I didn't print it here, but we could see it would be the number 2, right? Let's do that like this. And actually, we can just do, just so you can see it's the same thing. Let's just print X here. And we can see that's X plus 0, that's X plus 1. There's the address of X plus 0, plus 4 more bytes is the address of X plus 1. Here it is in memory, right? So array syntax, and hopefully we've kind of seen that in the JGrasp example, right? My array is this address here, plus 0, plus 1, 2, 3, you know, an offset a cell. And again, remember, this is abstract. In reality, this is going to be more than one actual memory cell. That's reflected in the actual address when we looked at it. And at the end of your array, we have more variables here. We could use, alternatively, this syntax to refer to the same items, right? My array plus 0 through 5. So we don't have to use the array syntax. We could use them interchangeably. And you could do the same thing if you had a pointer, which could be bad. What if we did something like this? X equals 10. And then we had ABC 1, 2 equals 3. And we'll do X pointer here equals the address of X. And now what we're going to do is print some number. And I want to print X plus 2. Now, X is not an array. right? But if I have the address, I can go to that address and skip as many cells as I want. And what did I do? Oh, X pointer. Skip as many cells as I want. And what did we get? Oh, it actually skipped this one. It got here. So here, I was here at X. Conveniently, it doesn't always happen this way. That was the next memory address, and that was the next memory address. It skipped 2 cells and got us the value of B. I think that's what happened. Let's see what happens if we do. Let's do this and actually just print A, B, and C. We'll do this. Instead of printing that, I'm just going to go over there and change it. Now let's compile it and run it. And you can see what happened. Sure enough, I wasn't supposed to, but because I knew where this address was, I was able to go modify the value of B unintentionally. This is actually a really bad thing. And this is something we won't get into security in this class, but with arrays, this is something that happens when you remember we talked about going out of bounds with arrays, and that C doesn't really stop you. It doesn't protect you. So in the same sense, if this were an array and I did something like this, or something like that, because you could use these interchangeably, they mean the same thing, then we could see that bad stuff could happen, right? All right, let's go back to the PowerPoint. Last exercise. What I would like you to do with the last exercise is create an array that can store 10 things. So the size of the array is 10. I want you to use a loop to populate it with 1 through 10. So it can store 10 things and it has the number 1 through 10 inside. Don't initialize it and declare it with a one-liner. Use a loop to do it. And instead of using array syntax, instead of doing this, I want you to do it this way. This is how I want you to go put values in the cells. That'll be the last exercise for the day, and then we are done with this. And then on Wednesday we'll do a graded exercise. So we're going to do a graded exercise on this Wednesday. Next Monday, we'll talk about a different part of pointers, allocating our own memory, and then we'll do another graded exercise next Wednesday. So let's try this, and then we are done for today. All right, let's try to do some of this together. So we need a loop, which means we need a loop variable. We need an array that can store 10 things. How do we say that? How do I make an array that can store 10 things in it? There we go, 10 in brackets. I can store 10 things. Now let's make our loop. So we'll start at 0. What is this middle section going to look like? When do I stop my loop? Less than 10. So as long as I is less than 10, I'll keep looping. We'll increase by 1 every time. And here I want to put 1 through 10 into positions 0 through 9 in my array, but I want to do it not like this. I want to do it using pointer arithmetic. So what would that look like? We'll do, instead of this, I want to use pointer arithmetic. How would this look different? Okay. So right. Like that?
Oh, no.
Interesting.
Yeah.
So that's one way to do it, I suppose. You got to be careful with that. So you can use arrays like pointers. There are some subtle differences. So let's explain what's happening here. If this is an address variable, I can dereference whatever address that is and do something with it. So initially it's pointing to the starting address, which is array plus 0. Then here we're actually changing the address of array so that the new starting address is the first element. So it's address plus 1. So that's changing the address of that variable. And the next time it loops, we're going to point to the next element. The only problem with that is if this does work this way, I'm not sure. Now, this may be one thing you can't do with interchangeably. You may have to have a, we'll try it in a minute. You may have to have a pointer variable to do it. The only problem with this is that that's a permanent change. So in the future, when I type in array, it's always going to point to the last thing, or the next to the last thing, or the next to the last thing. And we don't always want that, right? We'd like to know that every time I type in array, it's going to point to the beginning, and then I can give it the offset that I want. I don't want to have to remember to subtract 2, add 3, subtract 4. You know, that's not something we want to do. Let's try it and see if it'll let us do it. Yeah, it actually it won't let us do it because it's an array. If it were a pointer, it would let us do it. So that's neat though. Typically, that is not something we want to do though. More appropriately, what we can do is say, go to that starting address and add this much of an offset to it and dereference that. So we're not actually changing the address of that variable. We don't want to change the address. I just want to do, typically when you're working with arrays anyway, it's address plus offset, and that's the behavior we want to imitate. And if we were to do that and then print it, we'd see that sure enough, it should have the desired effect, right? 1 through 10. Very good. Interesting though, and that is something that people do with pointers, but what you would do is almost the same, but even if they were, you wouldn't want to do that. So with an array, you would want to make, with pointers, you would want to make a second pointer. And you do that to that second pointer that you're going to throw away. And the first one, you don't really mess with it. We are out of time. Thank you all. And I will see you on Wednesday. See you on Wednesday, those that are coming, and we'll have a graded exercise on Vocarium.